Hello, my expert chemists. Today, we are going to talk about the value of KQ a little bit more and what it means. So remember last time we talked about KQ telling us whether your reaction is reactant favored or if it's product favored, right? And so we had said that if you have a reaction A forming B, my KQ expression is going to be the concentration of the product, which is B, over the concentration of the reactant, which is A, raised to the power of their coefficients, of course. So we said if KQ is greater than 1, then that means that this reaction is product favored. So there is more B than A at equilibrium. If K is less than 1, that means it is reactant favored. There's more A than B at equilibrium. And we talked about K being a constant. And so is it really a constant all the time, or is there anything that causes the value of K to change? So let's look at the stresses that we had discussed before when we talked about Le Chatelier's principle and see if these stresses will affect the value of K. So let's first look at concentration and whether concentration is going to affect the value of K. So concentration changes. So let's say that I increase my A. Okay, so if I increase the concentration of A, so this value becomes higher, right? What happens? Well, we said that this stresses the equilibrium and it makes the equilibrium shift to the right to use up that A, right? And so what happens? Well, my value of B increases. So this also increases. So since both increase, they actually increase by the same factor, and it ends up that K remains the same. It does not change. All right. What if I decrease A? So this number goes down. Well, if I decreased A, what's going to happen? Which way is it going to shift? Well, it's going to shift to the left to make up more A, right? And so my B will go down because it's used up to make some A. Both will go down. My K remains the same. Same thing with B. What if I increase B? This goes up, right? Which way would it shift? It's going to shift to the left to use up that B to make more A. Again, ratio remains the same. So K is not affected by changes in concentration. Changes in concentration have no effect on the equilibrium constant. Okay, let's look at the next type of stress. What if I change the temperature? Well, temperature actually affects K, but it affects it in different ways whether your reaction is exothermic or endothermic. Let's look at how. So let's first look at if it is endothermic. Okay, so if it is endothermic, that means heat is written on the reactant side. Now, what if I heat my reaction? What is going to happen? Well, if I heat up my reaction, it's going to shift to the right to use up that heat, correct? So it's going to shift to the right. So it's going to produce more B. So this number increases. Now, did I also increase A? No. So I used up my heat, used up some of A to move to the left to make more B. So I increased my B without increasing my A. And so now this ratio is higher because B is higher and A is not higher. And so if I heat my reaction and it's endothermic, K increases. Okay. What if I cool my reaction? Oops. I should say cool. So let's look at what happens. So if I cool my reaction, I'm removing some of that heat. So I'm disturbing my reaction by removing heat. I don't have as much heat now. Which way it's going to shift? It will shift to the left. When it shifts to the left, I make more A. This number increases. Did I make more B? No. So this number is increasing, but this number is not. So the value for K will actually change. It will become smaller. So K will decrease. Now, let's look at what if it's exothermic. Okay, so if I change my temperature and it's exothermic, remember exothermic heat is released, and so heat is considered as being produced, and so it goes on the product side. So what if I heat my reaction? I increase the temperature, right? Heat it up. So if I heat up this reaction, now I have too much heat. I need to get rid of that heat. Which way would it shift? It's going to shift to the left to use up that heat. So when it shifts to the left, I increase my value of A. Did I increase B as well? No. I only increased A. What's going to happen to the value of KQ? It's going to get smaller. So if I heat up an exothermic reaction, KQ decreases. Let's look at if I cool it down. If I cool down my reaction, put it in an ice bath, lower its temperature, what's going to happen? Well, if I remove some of that heat, now it's too cold, I need to add more heat. What do? I shift to the right. When it shifts to the right, it produces more B. Did I produce more A? No, I did not. So I have more B, but no more A. My KQ will increase. So again, we see that with endo and exothermic, the shifts are opposite, and so the value of K will increase or decrease in opposite ways. The only thing that changes the value of KQ is the temperature. Like we saw a little bit earlier, changes in concentration will not change the value of your K. Only temperature will. And that's why in all the problems that we've seen, whenever it gives you a value for K, it lists what temperature that is under. Whenever you look up in a CRC book, or if you Google online or something like that, and you look up a value of the KQ, it will always tell you what temperature that KQ is at, because it changes with changing temperature. All right, that is it for the lesson today. We have one more lesson in chapter 18, and that is it. Have a wonderful rest of your day.